All right, my friends, every now and again I'll get some pushback on my take about CO2, carbon dioxide, and whether or not we're all going to burn on global warming / climate change, and why I don't believe the scientists and things of that nature. And actually, I do believe the scientists. I think there's lots of scientists who say CO2 is not the enemy. CO2 is certainly more in the atmosphere now than it was ever. Anyone who argues that would be silly, but is that a bad thing? And I frankly don't believe it is. The Earth is becoming greener because of increased CO2 for sure. Whether it leads to negative results of climate change, who knows? Am I worried about it? No, not in the least. But if I were worried about it, then I would want to do things to reduce my CO2. And I'll get into some of those things right now, as opposed to saying we can meet our demand of consumption with solar and with solar photovoltaic, but even thermal solar and wind. It's not going to happen. You're not going to happen to meet the demand required. The supply from these two sources of primarily renewables simply isn't going to happen. We can talk about biomass all we want. Biomass is a wonderful renewable for sure, but when you're shipping biomass from virgin North Carolina forest or a Canadian forest into UK so they can meet their green energy renewable numbers, that's not a net win in terms of reduction of carbon dioxide. It's just not, because you're shipping that from the Atlantic, not on a wind-powered sail. You're shipping it via fossil fuel. So I just want to reach, and I've done this a couple times, well, probably one other time I'm going to do it again. Planes. And this is from my man, David McKay, Sustainable Energy Without the Hot Air, which he has since passed. This guy, I got, again, Reason Debate. I came across David McKay because of a guy, Reason Debate, who told me, hey, you should look at this guy. I said, okay. And it was wonderful. He's a guy who literally lived the green life, but he said, look, unless we reduce consumption significantly, it's all pipe dream. We're not going to get a reduction in CO2 living the same way we are today. It's just not. So this book was written in 2007. You can get it for free. I'll put a link in the show notes. You should get it because I refer to this all the time, as a matter of fact. All right, so planes. Imagine that you make one intercontinental trip per year by plane. How much energy does that cost? A Boeing 747-400 with 240,000 liters of fuel carries 416 passengers, about 8,800 miles. And fuel's calorific value is 10 kilowatt hours per liter. We learned that in chapter 3, so we can go back to the chapters and read that. So the energy cost of one full distance round trip on such a plane, if divided equally among the passengers, is 12,000 kilowatt hours per passenger. If you make one such trip per year, your average energy consumption per day is 33 kilowatt hours per day. That's per passenger. So remember that. If the energy cost of one full distance round trip on such a plane, if divided equal among the 416 passengers, is 12,000 kilowatt hours per passenger. Divide that by 365 days in a year, that's 33 kilowatt hours per day. And I've said this before, and I'll say it until I'm blue in the face. We use, my house, a family of 6, about 60 kilowatt hours per day here in electricity. All right, 60 just electricity, not total consumption. So essentially, your round trip, on that one round trip throughout the year, just one time, one round trip from Cape Town to London, was more than half of the entire per day, was equal to more than half per day of the entire electricity that my whole family of 6 uses per day. That's how extensive airplane travel is in terms of waste, if you will, of energy consumption, of spewing of CO2. Let's make that clear what this means. Flying once per year has an energy cost slightly bigger than leaving a 1 kilowatt electric fire on nonstop 24 hours a day, all year long, 365. Think about it. 1 kilowatt electric fire on nonstop 24 hours a day all year. Flying is actually, that's about 20% more energy consumption than leaving that 1 kilowatt fan 24 hours a day, 365. That's nuts. All right, so what would you do? Individual action. And he gives us a list of things you should do. And number 1 on that list is stop flying. If you stop flying, you'll save on average about 35 kilowatt hours per day. Number 2, put a Willie jumper on and turn down your heating thermostat. Now, in the States, we always get, yeah, you guys you use too much air conditioning. I always laugh. How come no one talks about the heat that the good folks in Europe use? You guys use a lot of heat, and that is a big, big consumption. It takes a whole lot more to heat your home than it does to air condition. Why? Because it gets so much colder. I mean, you're talking, let's say 25 degrees Fahrenheit. You want it up to 68. Whatever that is, that's 43 degrees. You got to heat it up for space heating. Air conditioning in Atlanta is, let's say, 95 degrees, and we want it down to 70. It's 25 degrees. We got to cool it. All right. So put on a Willie jumper and turn down your heater's thermostat to 15 or 17 degrees Celsius. Put individual thermostats on all radiators. Make sure the heating's off when no one's home, and do the same at work. All right. And that can save 20 kilowatt hours per day. The number one thing is flying, though. Let's see. Number 2, don't buy clutter. Avoid packaging. So if you're green and you're using Amazon on a regular basis, you're wrong. He talks about eat vegetarian 6 days out of 7 because we know the methane gas from those cow farts and whatnot. But, you know, that would save 10 kilowatt hours per day if you want. I'm not doing that. But you could, for sure. Drive less. Drive more slowly. Drive more gently. Carpool. Use an electric car. Notice he does say hybrid, an electric. Join a car club, cycle, walk, use trains and buses. That will save about 20 kilowatt hours a day. Changing lights from fluorescent to fluorescent or LED would save about 4 kilowatt hours a day from your incandescent. Keep using old gadgets, e.g. computers. Don't replace them early. That'll save 4 kilowatt hours per day. Read all your meters, gas, electricity, water, every week, and identify easy changes to reduce consumption, switching things off. Compare competitively with a friend. Read the meters at your place of work, too, creating a perpetual live energy audit. So all those things can do a lot to reduce it, but number one by far is stop flying. 35 kilowatt hours per day if you just didn't fly. Number 2, turn down your thermostat to 20 kilowatt hours per day. Tied with number 2 is drive less, 20 kilowatt hours per day. And then don't buy clutter, avoid packaging is another 20 kilowatt hours a day. And you think about it, because they're shipping stuff from China. How does that get to your house? Well, if it's being shipped from China, right? I mean, they're not using a sail to move it overseas from over the Atlantic or over the Pacific Ocean. They're using fossil fuel driven boats. That's what's happening. And then on top of that, your FedEx or Amazon or USPS truck is still getting you. Use most likely gasoline, diesel. There might be some electric there, but even that's still got to be, the battery's got to be charged. So to get from China to your living room is a significant consumption. Never mind the packaging, just a cardboard box, is everything that goes in to move the product. And so, but flying is number 1. Now, just real quick, so a lot of people say, but Josh, technology is going to increase efficiency of solar. I used to believe that until I read The Physicist, and we can realize real quickly it's just not going to happen. So, a device with efficiency greater than 30% would be quite remarkable. Now we're talking photovoltaic here, which is again turning the sun's energy into electricity. The Shockley-Quisser limit says that at most 31% of energy in sunlight can be converted to electricity. The main reason for this is that a standard solar material has a property called its band gap, which defines a particular energy of photon that material converts most efficiently. Sunlight contains photons with many energies. Photons with energy below the band gap are not used at all. Photons with energy greater than the band gap may be captured, but all their energy in excess of the band gap is lost. The Shockley-Quisser limit for solar panels with concentrators is 41% efficiency. The only way to beat that limit is to make fancy photovoltaic devices that split the light into different wavelengths, processing each wavelength range with its own personalized band gap. These are called multi-junction photovoltaics. Recently, multi-junction photovoltaics with optimal concentrators have been reported to be about 40% efficient. And you can look at spectrolab.com. In July 2007, the University of Delaware reported 42.8% efficiency with 20 times concentration. In August 2008, NREL reported 40.8% efficiency with 326 times concentration. Strangely, both these results were called world efficiency record. What multiple junction devices are available in the market now? Again, this is 10 years ago. Unisolar cell, a thin film triple junction 58 watt peak panel with an area of 1 meter square. That implies an efficiency in full sunlight of 5.8%. So you just, the physics of it just, I'm telling you, you're not going to get beyond, I mean, for mass marketing, or mass consumption of photovoltaic PV panels, it's going to be tough, man, to get over 25%. I mean, I'd even say that's going to be tough. So let's just say 15 to 25% efficiency. So if the sun generates in Atlanta 170 watts per meter square on average, that's night and day, all right? Because you can't get photovoltaic or solar when it's dark out. So if the sun generates between 12 a.m. to 12 p.m. on average, 170 watts per meter square. That's what we get from the sun here in Atlanta. If you're up in Portland, Maine, it's about 140. If you're in Los Angeles, it's about 220. So on average in the U.S., about 180, 170, 180. I mean, if you that's all you're getting, man. All right. So if you have a 25% efficiency panel, so you take 180 times by 0.25, and that's what you're getting. What is that, like 45 or something like that, watts per meter square? And that's it, man. That's what you're getting. You times that by 24, and that's your number of kilowatt hours. You're getting about a kilowatt hour per meter square with a pretty high efficiency solar PV panel, photovoltaic. Wind's even worse, man. Wind's horrible. So, I mean, I know it's bad news, but so you're just not going to replace the energy that you consume with solar photovoltaic. You're just not. Certainly not rooftop. It's not going to happen. You're not getting it from wind turbines either. It's not going to happen. The number one thing you can do is you reduce your consumption, and the number one thing is stop flying. That's literally what you got to do. I mean, I'm telling you right now. Or we go nuclear, and I don't know why everyone's so anti-nuclear. Nuclear is a wonderful resource for sure. If you're worried about CO2 and you want to keep your standard of living, nuclear is the only option. We just have to come to that. We have to acknowledge that. Most greenies who recognize this, James Lovelock, I can't remember his name, the guy who wrote the Gaia book. I keep forgetting his name. Talk about just reading some other guy from another environmentalist who's on the Obama energy efficiency thing. He was talking about that nuclear is the answer for sure. But nuclear for some reason makes everyone scared of the China syndrome. We're gonna melt. We're gonna have Mr. Burns with fish with 20 eyes and stuff like that. And just if you look at I just won't go into it, but if you just look at the damage nuclear has cost relative to smoke inhalation from heating with firewood in these third world countries and things like that, nuclear is literally nothing relative to the risk that's out there right now by what the third world is dealing with their lack of energy that they're receiving, lack of heating, lack of cooking material and things, using dung, using trees to heat, to cook. They're breathing this stuff in. It's horrible, horrible. And we have this wonderful thing called nuclear, and just people are scared of it. And, I tell you, the media's done a good job scaring people. It's sad because we could be using nuclear, reduce our CO2, and maintain our standard of living, and just literally lift people out of poverty in these third world nations. But sad that we don't. Anyway, all right, hey, that's my take. I'll put a link to the show notes. I'm going to probably do this once every 3 months because this is so important. Cheap electricity, cheap energy is so important to a stabilized society for sure, and it's so important to our standard of living. And the whole point about retirement planning is maintaining or a standard of living that you want, regardless of maintaining it or just choosing your standard of living. That's fine, but you have to choose it. And the first thing that's going to come with that is obviously money. But number two is where are you going to get the energy for that? I mean, where's it going to come from? If you're living in northern New England and you got to pay huge spot prices for natural gas in which to heat your home, that's going to reduce your standard of living. And it's all based on this idea that fracking is leading to pollution, CO2 increasing, and it's just a sad, man. And there is a solution called nuclear. All right, we'll see you guys next time. Thanks.